In order to detect and correct errors, we need to do coding. Coding is nothing but adding redundant bits in a particular way or systematic way. So for that we have various mechanisms. So one category is called block coding, second one convolution coding, and we also have other coding schemes. So convolution coding is not very important because and even it is not popular because the reasoning and analysis of these coding schemes are very difficult. Okay, so what is analysis here, sir? Example, let's say you have a code word using convolution coding, right? Now you want to know what is the capability of such code words. Will they detect 1-bit errors? Will they detect burst errors? You want to know. This is called analysis. Okay, so analysis part will be very difficult here. That's why it is not popular. So we have another popular model, that is block code. In block coding, we have linear coding and cyclic coding. So we will see the details later. Before that, I would like to introduce you a concept called Hamming distance. So this Hamming distance is going to help you in understanding the relationship between error detecting and error correcting capabilities and code words. So that's why first we learn what is Hamming distance. Let me begin with that. Example, let's say you have a block code. Block code means what, sir? Block code is nothing but it's a code where your message is divided into particular blocks. Fine. So maybe I can assume that each block size 4. Fine. And each block is coded separately. That means there is no relationship between the blocks. Example, if you have a message 01011101, then maybe if I use block coding with the length of the block as 2, then this will become the model. Like every 2 bits will be grouped and code word will be added to every message or every block. That's it. This is about block code. Now Hamming distance is nothing but, example, if you have two blocks 0101 and 1010, the number of bit differences, if you see here, there is a difference, correct? Let me mark it. 10, there is a difference, there is a difference, there is a difference. So in 4 places these two blocks differ, right? So that is called Hamming distance. Understand? Now example 1100 and 1101, there is only 1 bit difference. This is Hamming distance. Now let me introduce you minimum Hamming distance. Minimum Hamming distance actually is defined for a system. Let me take system of messages like 010, 101, 110, 001. Okay, right. So here my intention is you have a system of patterns. I want to calculate minimum Hamming distance. For that, what you have to do is you have to take every two combination and you have to compute Hamming distance. Fine. After that, we have to find out the minimum value among all such Hamming distances. Let me take A comma B first. We have A, B, C, D. So let's do Hamming distance of A comma B. So that is, if you see 011001, right, 3-bit difference. Hamming distance of A comma B is 3. Similarly, let me compute for A comma C, A comma D, then B comma C, B comma D, then C comma D. For A comma C, if you see 010110, 01, one difference, right, only one difference. Now A comma D, A comma D, 010001. So the difference is 2. Now B comma C, if you see B 101 and 110, the difference is 2. Now B comma D 101001. So 1 and only 1, right? Okay. So Hamming distance between C comma D 110001. 1, 2, 3. Right. So if you see all, what is minimum value? 1. So here for this system, minimum Hamming distance is 1. So this minimum Hamming distance is going to help in analysis of error detecting and error correcting capabilities. Okay, let's do that. Now we will see how minimum Hamming distance is going to help us in detecting 1-bit errors. Further, let me take a code system where minimum Hamming distance of that system is 2. That means I can say that if you compute any Hamming distance between two valid code words, you get always greater than or equal to 2, right? So now V1 is such code word 00101. So what I am doing is I am showing you all the error patterns which are having exactly 1 bit error. That means if I intentionally make this bit as 1, then you get 10101, that is a 1 bit error in 00101. Similarly, you will have 5 such 1 bit errors, correct? So maybe you can have 1 bit error here or here or here or here, right? So E1, E2, E3, E4, E5 are such patterns. Now what I want to say is, if really minimum Hamming distance is 2, then these errors E1 or E2 or E3 or E4 or E5 cannot be valid patterns. Why, sir? See, initially your pattern is V1, right? Now V1 and this error is having exactly 1 bit distance, right? But we know that in our system our valid patterns are such a way that their Hamming distance is greater than or equal to 2. So that's why E1 cannot be a valid pattern, remember it. So no error, no 1 bit error of V1 can be a valid pattern. So that is going to be trick where receiver is going to play. Fine. Now first of all we'll see how receiver is going to interpret the things. Example, if you send a message or code word V1 and there is no error for simplicity, what is going to happen we will see. Your receiver will have all the valid patterns V1, V2, V3, V4 as a table. So it computes Hamming distance between all that valid patterns and the received pattern. Example, here V2, V1, V3, V1, V4, V1. Let's compute Hamming distances. So D of V1, V1 will be 0. D of V2, V1, because these two are different patterns, then you get definitely a value which is greater than or equal to 2. We know this is a rule for that. D of V3, V1 will be greater than or equal to 2. D of V4, V1 will be greater than or equal to 2. So now, what if error comes? Example, if you set V1 and if you get E1, what is going to happen? If same thing is computed, so D of V1 comma E1 and D of V2 comma E1, so on. So definitely this we know that E1 cannot be any of the valid patterns. So in these places none of the row will have a 0 value. Agree or not? Here you have 0 value. Why? Because we have a received message equal to one of the valid code word. But here since E1 is not a valid code word, so it will not match to anything. So you would never see a 0 entry. Fine. Now, so this is a landmark. If you don't see any 0 entry, then definitely I can say that that is a error. Now here a student can ask a question. Sir, what if E1, though it has an error, it is matched to another valid code word? Example, you are sending V1, but if it becomes V2, that will not happen. That is what I explained you. Because of 1 bit error, your error pattern cannot turn into another valid pattern. That's what initially I explained. So definitely you never get 0 entry here. That's it. Now receiver will do this. It will compute all the Hamming distances. If one of them is 0, then that is a valid message. If none of them is 0, then definitely there is a 1 bit error. In that way it can detect. But remember, so only it will handle 1 bit errors. Why, sir? What if there is a 2 bit error? Then the concept will be completely wrong. Why? So if there is a 2 bit error, maybe the because of 2 bit error, that error, let's say E, then that E may turn into another valid message. That happens because see here. So 00101 is your message. Fine. So let me intentionally change some bits. 00101, right? Here you see. I change this pattern and this pattern. That means here if there is error and here there is an error, then what happens? It would become 0, 1, 1 complement 0 and 0, 1. That means because of two errors, so one valid message might become another valid message. But if there is only 1 bit error, definitely that cannot become another valid message. That's the trick of this. So now you want to understand, you have to understand this one. If you want to detect 1 bit errors, minimum Hamming distance we have to take 2, right? You understand that. Now we'll generalize it. How to design a system such a way that we can detect up to d bit errors. Simple. One point you remember, we have to design a system such a way that d min of that system should be greater than or equal to d plus 1. So minimum we have to take d plus 1. So that means what? Between any two valid messages, so automatically the Hamming distance will become greater than or equal to d plus 1. That's a trick. So why sir? Same story. Example, let's say V1 is such one valid message. So if this message has 1 bit error, then that will be turned into this point. If it has 2 bit errors, then it will turn into this point. So this point is nothing but a point on circle. So the distance between this point to this point is d. That means the Hamming distance between V1 and that pattern is d. Still this cannot be a valid message. Why? Because between any two valid messages the distance is greater than or equal to d plus 1. So finally all the points on that circle are still invalid patterns, right? They cannot become another valid pattern. Now that is going to be used by your receiver. So what receiver will do is, really in this in the medium we are getting up to d bit errors, not more than that. Then your valid message cannot become another valid message. Because of that, if I compute here distance of V1 with that example, let's say the received word is x, then d of V1 comma x, d of V2 comma x, so on. So what happens, we'll see. If the received word doesn't have any errors, then what happens? Example, let's say if you send V1, then if you receive again V1, then distance of V1 will become 0. That is a landmark to say that there is no error in the system. Now, what if it has errors up to, let's say, d bits? So because of that, already you know that resultant pattern cannot be any valid pattern. So if you apply again d, distance between that pattern and V1, V2 and all, so you never get 0. Why sir? To get 0 entry, so that x should become another valid pattern, because x is an error. So then that cannot be. Example, here you are sending V1, right? So you are getting x. If x is V1 means no error, but x has errors, but it is becoming another valid pattern, then only here you get 0, correct? But that won't happen. Why? Because of d bit errors, one valid pattern is not becoming another valid pattern. So that's why cleverly we planned minimum Hamming distance of the system as d plus 1. So finally what I want to say is, if system has minimum Hamming distance as d plus 1, then such code system can detect up to d errors. Fine.